I'm going to be solving question 32 from chapter 19 of the night textbook. This question says, a monatomic gas follows the process 1 to 2 to 3 shown in the figure. How much heat is needed for process 1 to 2 and process 2 to 3? So this is process 1, 2, and 3. So we want to figure out how much heat it takes for it to go from here to here and from here to here. So first, we know that our ideal gas equation that we can use is CV equals 3 over 2R. And this is just from the textbook. So this is going to be for a monatomic gas. And then for a diatomic gas, it's going to be CP equals 5 over 2R. And then from there, we could write down our known values. So pressure 1 is 3 atmospheres, which converts to 3.01 times 10 to the 5th pascals. Pressure 2 is also 3 atmospheres. And then this is going to be the same. And the pressure 3 is 1 atmosphere. We also know volume 1 and volume 2 as well as 3. So volume 1 is 100 centimeters cubed, and we want this in meters cubed. So 100 times 10 to the negative 6. Volume 2 and 3 are the same, so we're going to write that like this, which is going to be 300 times 10 to the negative 6 meters cubed. Okay, so now we want to find the process, the heat that it takes for it to go from process 1 to 2. So we're going to use the equation Q, which is say 1 to 2, is equal to the number of moles, the specific heat capacity, and the change in temperature. We know from our ideal gas law that PV equals nRT, therefore T in this case is equal to PV over nR. So we're going to rearrange the equation to get NCP, and because delta T means T2 minus T1, we're going to write this twice. So P2 V2 over nR minus P1 V1 over nR. So the moles are going to cancel out, and this leaves us with CP times the pressure over R times volume 2 minus volume 1. And we know that CP over R is equal to, in this case, it's a diatomic molecule, so we're going to use the second equation. So if you were to rearrange it, CP over R is equal to 5 over 2. So we just plug in the numbers. We get 5 over 2 times the pressure, which is 3.01 times 10 to the 5th, times V2 minus V1. So 300 minus 100 is 200 times 10 to the negative 6. This gives us 151.98. Now to find the heat from process 2 to 3, we're going to use a similar equation, which is CV over R times the pressure times volume minus pressure 2 times volume 2. CV over R was calculated above, which was 3/2 times 300 times 10 to the. And then, so we're only going to write this once since V2 is equal to V3. And then we're going to subtract the volumes from one another. So it's 1.01 times 10 to the 5th minus 3.01 times 10 to the 5th, which leaves us with negative 91.1. So this is the heat in joules to go from process 1 to 2, and this is the heat in joules to go from process 2 to 3.